Hi, today we are looking at derivatives of inverse trigonometric functions. So I have six different derivatives here. So we've got the derivative of the inverse of each of primary trig ratios, as well as the derivative of the inverse of each of our reciprocal ratios. So a derivative of the inverse of sine x is 1 over the square root of 1 minus x squared. Our derivative of of our inverse cos is negative 1 over square root of 1 minus x squared. Our derivative of tan inverse is 1 over 1 plus x squared. Our derivative of our inverse of cosecant is negative 1 over the absolute value of x times the square root of x squared minus 1. Our derivative of our inverse of secant is 1 over the absolute value of x times the square root of x squared minus 1. And our derivative of cotangent inverse is negative of 1 over 1 plus x squared. So we'll jump straight into some examples. So for example, differentiate sine negative 1 of 3x. Now, like I mentioned when we did our regular trig functions, when we're differentiating, we still have to remember to use our chain rule if it's applicable, which it will be in this case. So we know our derivative of sine negative 1 on the previous page, which was 1 over square root of 1 minus x squared. Now that's our derivative of sine negative 1x. In this case, we have 3x, so this x here would be replaced with a 3x. So that gives us y prime is equal to 1 over the square root of 1 minus 3x squared times the derivative of 3x. Now our derivative of 3x is just going to be 3, so that's y prime is equal to 3 over the square root of 1 minus 9x squared. Okay, so next we've got y is equal to cos negative 1 of sine x, and we only take the derivative of this. So first we'll take the derivative of our inverse of cos. So we've got y prime is equal to negative of 1 over the square root of 1 minus, because we had this in here, it's going to be sine squared x times, because of our derivative, the derivative of sine x. So that's negative of 1 over the square root of 1 minus sine squared x times our derivative of sine x, which is cos x. Now that would be negative cos x over the square root of 1 minus sine squared x. Now we can recognize we can simplify this using a Pythagorean identity. So this is y prime is equal to negative cos x over the square root of cos squared x. Continue this up here, so that gives us y prime is equal to negative cos x over, we can take the square root of cos squared, but that's going to give us the absolute value of cos x. Now this is going to give us a couple different answers depending on where our x value is. Because this one's always going to give us a positive version. Well, we could have a negative or positive here. So we're going to have y equals 1 if cos x is less than 0. So if cos x is less than 0, we'd have a negative here, canceling off this negative, giving us a positive, divided by the same value but positive, which gives us 1, which makes it negative 1 if cos x is greater than 0, because I'd mean cos x is positive, which means we'd have a negative times a positive, making this negative cos x over positive cos x, giving us negative 1. Next, we've got y equals the inverse of sine 1 minus x squared. And once again, we want to take our derivative of this. So our derivative of the inverse of sine is 1 over the square root of 1 minus what we had here, and then squared. So 1 minus x squared squared. And then that's going to be multiplied by the derivative of 1 minus x squared. Okay, so this denominator will expand out and collect like terms. So when we expand this part out, we'll have a 1 times 1 giving us a positive 1. That's going to cancel out this 1 minus that positive 1. So I'll cancel out. We'll have a negative x and another negative x, giving us negative 2x. But we have a negative here, so that gives us positive 2x. And I should say x squared, because that wasn't just x, is x squared. And then we've got negative x squared times negative x squared, which is positive x squared. But we've got that negative in front, so that's minus x squared. Or sorry, x of 4. And then that's times our derivative of 1 minus x squared, which is negative 2x. Okay, so we'll go through and simplify things a bit. So we've got negative 2x over we can factor an x squared out of both of those. So we've got square root of x squared times 2 minus x squared. Now, because we factored this out, we can bring it out to the front. So that gives us y prime is equal to negative 2x over the absolute value of x times the root of 2 minus x squared. Now, our x's can cancel out, and depending on if this x is positive or negative, we'll have two different answers. So we're going to have y prime is equal to 2 over the square root of 2 minus x squared when x is less than 0. That's because when x is less than 0, it'll be negative and cancel this negative, and then our x's just cancel out. So I'll leave us with positive up there. Or it will be negative 2 over the square root of 2 minus x squared when x is greater than 0. Because if it's greater than 0, we won't have anything to cancel off that negative. Okay, so we'll do one more example. So we have find the equation of a tangent line to a curve y equals tan negative 1 x squared at x equals the square root of 3. So first thing we might as well do is figure out what our y value is at this location. So that's the same as saying f of root 3 is equal to tan negative 1 of root 3 squared. Now tan negative 1 of root 3 is pi over 3. So we'd have pi over 3 squared. So we have pi over 9. So we know our coordinate that we're going to use in our equation is going to be root 3 comma pi over 9. And I realized I made a mistake here. I remembered to square our denominator, but I didn't square the numerator, so it'd be pi squared over 9. So this is our tangent point. Now we're going to find y prime. So we have to follow chain rule. So the first thing we're going to do is take the derivative of its exponent. So we're just going to have 2 times tan negative 1 of x times d dx of tan negative 1 of x. So that works out to be 2 tan negative 1 of x times 1 over 1 plus x squared. Or we could rewrite this as y prime is equal to 2 times the inverse of tan over 1 plus x squared. So now we want to find our slope at that point. So we'll substitute root 3 in for x's. So we've got 2 tan negative 1 of root 3 over 1 plus root 3 squared. So that gives us 2 times tan negative 1 of root 3, which we already talked about was pi over 3, divided by essentially 1 plus 3. That'd be 2 pi over 3 divided by 4. So that would be 2 pi over 12, which is pi over 6. So writing out our equation point slope form, so y minus y1 equals m times x minus x1. That gives us y minus pi squared over 9 equals pi over 6 times x minus pi over, or sorry, minus root 3.